Okay, so this one is a demonstration of how to apply Mann or Mann-Whitney U test calculator. So as usually, the first part of the calculator is dedicated to different parameters which we could configure. Let's discuss them briefly. So first of all is actually the hypothesis, and as you're able to see here are several options, but actually we need to stop with the default value. So as you're able to recognize, the hypothesis is, or alternative hypothesis is, that there is a significant difference between group 1 and group 2. Again, under groups here we are understanding simulated values and real values. So we are not going to provide any changes for a significance level. This one is a quite standard value. Outliers are included. We are not going to exclude. The method is set to automatic. And the next one, what we need to enter is actually the data. So just not to confuse you, I already inserted all the necessary data, so no copy paste anymore. So the data is already here. So a simulated data and real data. So the simulated is the one which we get from a simulation model. And again, the next, what we just need to do, just press the calculate, and immediately we are receiving the result. So please don't be confused that you are not able to see a following part of the screen. We are not going to discuss the output which we have received. But what we are definitely going to discuss, how actually make the conclusion about the test results. And here we have some value which is called a p-value. You are able to recognize the specific value which we got from calculations. And now what we need to catch up is how to use the following p-value to make the conclusion about validation results. So actually here is a short description, and the description actually says that if a p-value is higher than alpha, and alpha is something what we have provided here, so alpha is a significance level. In this case, we are not able to reject null, or sometimes we are calling it main hypothesis. But our main hypothesis was that there are no significant difference between group 1 and group 2. So probably the last thing which I would like to pay your attention in this tutorial is regarding main hypothesis and the something which is entered here. Please pay attention that index is different. So I mean that for main hypothesis it is indicated 0, and the main hypothesis that there are no significant difference between the groups. Here is indicated alternative hypothesis, which says there are significant difference between the groups. So we have completed a test using a Mann-Whitney U test. Okay, so we are moving to the next test, and this one would be t-test, really very popular test. And again, as usually, we are starting with a configuration. So quite a lot of fields to be configured, but in overall for our purpose, we are just leaving the parameters by default. So as before, probably I would like to pay your attention to a following. So it is, there are some options, but as I have stated, we are selecting the default, and let's discuss a bit what is stated here. So it is stated that our alternative hypothesis is that actually the mean of first group is significantly different with the mean of the second group plus some d, which is difference. And here I would like to pay your attention that by default d, difference, is indicated as 0, meaning that our alternative hypothesis is that mean for first group is significantly different from mean of the second group. So significance level alpha is still the same. Outliers are included. We are not going to exclude something, and by this we could provide the data. So we have raw data. That's why by pressing enter raw data button we are receiving the following interface. Just to make it a bit more user-friendly, we will state that here we have simulated data, so data from simulation, and here we have a data from real observations. And in this case, I will enter or copy paste the data. So let it be that this one is a simulated data, and a following one will be the real data. So after entering the data, going down, we have a few buttons, but in this case we are just pressing calculate the sample. So again, we are not going to discuss the data which are provided here. We are going to run the test, so that's why we just need to press another big blue button. Okay, maybe not so big, but still blue, calculate test. So after pressing calculate test, we are receiving quite a lot of information, but again, please pay attention that we are going to concentrate our attention to a p-value. So I didn't mention before, but if you would pay your attention right now, the indicator is actually showing us to the green zone. So for us, it's a positive sign. But let's go to the decision making, okay? Because we need to make the decision. A model is valid or not. And here the approach is still the same. If a p-value is higher than alpha, so a main hypothesis cannot be rejected. So in our case, again, a p-value is indicated here, alpha is indicated here, and it's quite clear that a p-value is higher than alpha value. So the conclusion from this one is that we are able to recognize that model is valid, at least in terms that there are no significant, or better to use a word, statistical difference between mean values. So from simulated values and from real values. Okay, so finally, I would like to present you a Kolmogorov-Smirnov test. By clicking the link, you will get the following screen, which is indicating that it's a Kolmogorov-Smirnov test calculator. As usually, we have some configuration screen. And as you're able to recognize, I did already a dirty work, meaning that I have already indicated that one set of the data would be called a simulation, so produced by simulation model. The second one is real data. No changes here. I mean that there are few options, but we are not making any changes here. And probably here a bit of explanation shall be provided. So if you would pay your attention, alternative hypothesis is indicated in the following way, that there is a significant difference between cumulative distribution function of first data set and the second data set. So, to be honest, following one means that we are putting much more strict, what strict would be correct here, much more strict validation conditions. So we are not asking that means are not significantly different, but we are asking that a distribution is not significantly different. So no changes for significance level, and as you're able to recognize, I have already provided the input for the data. So what we just need to press a calculate button, and immediately what we receive. Unfortunately, no beautiful diagrams here as it was before, but still we have received all the necessary information to make the decision. So meaning that a p-value is calculated, so you are able to recognize what is the specific value, and as usually we need to compare a p-value with alpha. And if p-value is higher, then in this case the main hypothesis is not rejected. So as you're able to recognize, this one is exactly our case. And again, sorry for being so noisy, but I would like to go back and repeat one more time that our main hypothesis was that there are no significant difference between distribution functions of two data sets. So in this case, again, we are receiving the result that there are no significant difference, and finally this one leads us to the conclusion that a model is valid.